Now we're looking at separations, and I want to look at how we separate particles that are really quite close in size. So some particles that are big and mixed with something that's quite small, it's easy to separate them with a sieve or a filter. When they're very similar size, it gets harder and harder. One of the techniques we have for separating things that are the same sort of size but slightly different is called chromatography. This one's quite interesting. There's a few things going on though. So the first thing I want to have a look at is if you've got some paper towel, and I've got a few pieces here, you can do some chromatography with paper towel. Now if I put a drop of food colouring on my piece of paper towel, you should see that there's a change, and you should see that there's some kind of movement. So I'm just going to use a drop of blue coloured dye. Now if I put it on the middle, you can see that it spreads out quite well and it moves through the paper. If I add a drop of water to it, you can see that it starts to move, and if I keep on adding water, it keeps on moving. And you remember what we said about forces? So whenever there's motion or movement, that means that there's a force involved. And Newton went further than saying there's just one force involved. He said that even if there are other forces involved, they're not balanced. So there's a force involved when you add some food dye to the paper towel, and then you add some water as well. So there's a little bit of movement there. If I use my paper towel and I tip it upwards so that when I add the water, let's see if the water drops go down due to gravity. So I would expect water drops would go down. The force of gravity should be working here. The force of gravity should be working all the time. And I can see it going down pretty quickly. Did you notice that some of it's going up though? Now the interesting thing with chromatography is that it can go up against gravity. So let's just try this where we've got a drop of food colouring. And these are quite big drops, it's making it a little bit hard. And I put my paper towel uphill, and I put the water below. So I'm putting some water below the colour, and I'm going to see if the motion can go uphill. Now, it takes a little bit longer because it's working against gravity, but there is some movement and it's going against gravity. It's not gravity that's making it move upwards. So what could it be? Well, there's a force that you might not have heard of before. There's a force of attraction that's happening with the paper and the water. And as the water is being attracted to the paper and it's moving through the paper, it's being absorbed through the paper, it's just carrying with it some of the really tiny particles of dye. Now, do you think that some of those particles were a mixture, or were they a pure substance? I can see a few different colours starting to form here. I think we need to have a clean board again, and try not to do this on your bench. Try to do it on a board or something plastic. I've got a lid here that's quite good. What I'm going to do is put my paper towel that I'm testing on the side, or I'm going to stick it to the side and add my water below. So you can test it, food colouring and food dyes this way. What I've done is I've added some of the food colouring and food dyes and made a mixture on purpose. And instead of doing really big drops, I'm just going to use like a paintbrush to make a really tiny dot that's quite concentrated. So lots and lots of dye in one spot. And then I'm going to add some water below, not on the dot, just below the dot. And I'll keep on adding drops just at the bottom there until we start to see something changing. So gravity is not the force that's working here. There's an absorption force that's working through the paper. And as it moves, it's dragging with it particles, all the particles that it comes across. But what might separate the particles, because I'm starting to see one colour here and a different colour here. Well, gravity can still keep working, and the particles that are very heavy don't get dragged as far up through the paper as the particles that are light. So I'm starting to see some red here, and I'm starting to see some blue and green up here, which tell me the particles have different weights, or they have different masses, and they're moving through the paper differently. Now you can test out all sorts of things this way, chromatography. Why not try testing out some textures and some food colouring? This one's still going, by the way. I'll leave it here for a minute to keep going. If you're going to use some different textures, why not have a few bits of paper and test out some different textures? Got one here that's black, and I'll make a mark on my paper. I've got one here that's blue. I've got one here that's purple. Now, to keep it fair, what I want to do is give them the same amount of water at the same time and make it move up through the paper rather than down. So I'm going to make a line of water that you can add to. You can see how quickly it goes through the paper there. Now for my black texture, what do you notice? There's a lot of purple coming out of it. What do you notice for my purple texture? There's some blue coming out of it. So you can start to see the particles that were in the texture ink, and you can see which ones were pure and which ones were a mixture. My blue looks like it was one colour. My purple looks like it's two colours, so that was made of a mixture of colours. So, got some paper towel and some textures. Try some chromatography. There are some ways of separating that don't involve paper towel. I tried toilet paper. It was too soft, it didn't work very well. But there are some more complicated ways of separating solids, liquids and gases using chromatography. Maybe your research can be to have a look at what methods we use to separate things that are really similar size, like gases or liquids, using chromatography. Remember when I said that paper was very good at absorbing water, had a force of attraction for the water almost? Well, we can use that to do a really cool experiment, and what you'll need is a few different glasses and containers. But if you've already got some of these put aside for testing whether things dissolve, or you're ready to do that later on, that might work quite well. So what I want you to do is cut some paper towel so that it will go from one container into another. But because watching water move, it's a bit hard to tell what's going on. What I think we'll add is some food dye to our first container, and then we'll add some water to it. In the second container, we're not going to add anything at all, nothing at all. And what we should see is that the water is attracted to the paper, moves up through the paper, and even goes around the corner over the top and down into the next side. So you need a few pieces of paper, and you can make this extend past just 2 colours. You can use all sorts of different colours, and we'll add some water to the glasses. Make it about halfway up the glass. There's quite a bit of water there. About halfway up as well. Now as you're watching, it takes a little while because it's quite slow. As you're watching, you should see the paper getting wet, and you should see the solvent, that's the water, moving up through the paper. It's absorbed through the paper.